Hello and welcome to this PV Tech Tech Talk product series webinar co-hosted with Sungrow. The title of today's webinar is Tackling Heat, the Importance of Liquid Cooling in Hybrid Solar Storage Projects. My name is Liam Stoker and I'll be your moderator for today's webinar. And joining me today are Zvi Ben David, who's General Manager for Israel, and Jan Mu, who's European System Solution Manager, both of Sungrow Power. Now, before we start, some housekeeping. Today's webinar will last approximately 1 hour. Shortly, Zvi will open proceedings with an introduction, after which Jan will provide a deep dive into some of the technical details of Sungrow's liquid cooling energy storage solutions. Now, today's webinar will highlight some of the real technical details behind liquid cooling, so we'll save as much time as possible for your questions. You can submit questions using the dialog box on your screen, and feel free to do so throughout the webinar today. We'll work our way through as many questions today as we can, but if we are unable to get round to your question, please provide your email address and we'll liaise with you directly. The slides and a recording of today's webinar will also be available shortly after the presentation, so keep your eyes peeled on PV Tech and in your inbox for that. But without any further ado, I'll hand over to Zvi to begin today's webinar.
Thank you, Liam, for that kind introduction. And my name is Zvi Ben David. I'm the General Manager of Sungrow Israel, and we are thrilled to host you today for our hot topic of tackling the heat, the importance of liquid cooling and hybrid solar storage projects. PV Tech, together with our Sungrow team, including my honorable colleagues Jan Mu, who will be speaking after me, and Michelle Lee, who has been helping a lot, and myself, I put together an exciting webinar for you that I'm sure that you're going to enjoy. So let's begin. I'll start out with going through today's schedule of events throughout this webinar. So I'm going to talk to you a bit about an introduction to Sungrow. I will not be going too much into the corporate information, just focusing on the important points the way I see them. And then we'll jump right into the battery energy storage challenges. We'll be talking about the Sungrow liquid cooling energy storage system. Talk a lot about the AC coupled and DC coupled systems. Then we'll look at a few of our many global references, and we'll be ending up the session with questions and answers that you're welcome to post, as Liam has explained earlier on, so you can prepare those questions. Let's start out with one of the more important points that I see as being part of the Sungrow family. So you may know that Sungrow has been dedicated to conversion technology of clean energy for 25 years. Our headquarters are based in Hefei, China, and Hefei is a technology hub with plenty of opportunities for innovation. We started our business in Hefei, and we now have over 20 subsidiaries globally. One of the more interesting facts is that not only that we believe that we're good, but Bloomberg Energy Finance has also released its first inverter bankability report in July 2019. And they have found that Sungrow was the only manufacturer to be rated #1 bankable for 3 consecutive years. What does that mean? Bloomberg's ratings states that among global inverter firms, projects using the Sungrow inverters are more likely to obtain non-recourse debt financing from banks compared with other competitors. This is quite a crucial point for anybody who is looking to set up a solar energy project with the costs that are involved. So we're very happy and proud to have that rating from Bloomberg Finance, and we work hard to maintain that rating year after year. The second important point that I wanted to mention before going into our topic of today is the fact that Sungrow has been dedicated to giving our social responsibility. And I think that's a very important point. We continue to invest in our social responsibility initiatives worldwide as a way of demonstrating our commitment to the global market. For instance, we have set up technical courses, trainings, and colleges to inspire undergraduates of knowing more about solar and storage. By doing so, we also provide more choices for their careers. We also invest in the future by donating bookstores for underprivileged children, donating PV plants for rural primary schools, and offering scholarships at universities. Open days at Sungrow headquarters are always an attractive day for students, and teenagers can learn a lot about our energy in our Green Lab. Specifically in Israel, we have taken our initiative by, before even selling our first system, we have donated an energy storage system to Nerim in the Mountains. Nerim in the Mountains is an agricultural farm in the Golan Heights, which was established by the Nerim Association. The farm is a therapeutic framework for trainees who have reached difficult situations of deep crisis and dysfunction and lacking connectivity to the national grid. Nerim is dependent on off-grid energy resources. So together with our donating partners, Sungrow donated an off-grid energy storage system to Nerim in the Mountains. And this, as I mentioned, was the first thing that I personally did as general manager in Sungrow Israel for the energy storage market in Israel before we even sold our first project. So we truly believe in giving. So let's talk a bit about Sungrow worldwide. As I mentioned before, we have 20 international subsidiaries. We have 240 service outlets, and we are currently operating in at least 150 countries. The number grows every day. The whopping number of 224 gigawatt installments of our equipment is something that's mind-boggling, to my opinion. And we'll talk a bit about how we in Israel contributed to those numbers. So talking about the first project of energy storage with our liquid cooling systems in Israel. This is the largest Israel standalone energy storage project, which was signed in Q1 of this year. The Dalia Power Station, owned and operated by the Dalia Power Energies plant. It's a 912 megawatt combined cycle natural gas-fired plant in Israel, and it boasts 8% of the total electricity production in Israel. Located on the site of Dalia Power Station, the energy storage project is expected to be completed in the first quarter of 2023. We're talking about a 64 megawatt project that we have signed with them. The integration of the storage enables the gas generators to be turned down immediately without impacting reliability, as well as enabling them to operate at optimal efficiency when they are turned on, dramatically improving gas-fired station speed and flexibility, resulting in improved efficiencies and lower emissions. This agreement that we signed designates Sungrow to provide the ST2752UX energy storage system unit and its power conversion system, which is the SC5000UDMV, and enclosures, as well as providing maintenance service for the project. The innovative cooled energy storage system slashes capital and operating expenses due to its pre-assembled and easy installation design, as well as a more effective cell working environment, which substantially slows down the capacity loss rate. Furthermore, it enables a smaller footprint, given the back-to-back installation structure, which perfectly meets the demand of the existing gas-fired power plant and its land constraints. And there are many land constraints at this power plant that we had to cope with. As I mentioned, Jan will go more into how we are able to go ahead and cope with those challenges. So with Dalia Power Energies acting as a lead independent power producer, the IPP, and playing a proactive role in paving the way to the energy transition, the EPC company Afcon EPC division leads on the full planning, procurement, and execution, as well as operation and maintenance of the project. And this is planned for quite a long time. The next project that I'd like to discuss a bit about was actually signed before the Afcon project. This is at the end of Q4 2021 with Enlight Energy. And so the Enlight Energy company is an Israeli developer, an IPP. They have global operations across the US, Europe, and Israel. The Israeli government introduced last year a goal of generating 30% of the country's electricity needs through renewables by the year 2030, with solar PV expecting to contribute to the majority of this. About 26% should be through solar. And this is to the tune of 12 to 15 gigawatts of new PV installations in the coming decade. So in order to reach such a high proportion of the solar usage, the country is currently aiming to develop an advanced solar plus storage system to ensure the stability and reliability of the grid. With Enlight, we have signed an agreement of a total of 430 MWh, which is a combination of 230 MWh for the stage 1 the solar storage tender that came out for the government, another 200 megawatt as part of the solar storage 2 tender. And this will maximize the profitability, flexibility, and safety of the plant. And the third and last agreement that we have signed in Israel so far was the most recent one that was signed, which was with Doral, which was signed in Q1 2022. So Doral Energy Resources Group is a leading entrepreneurial company in the field of renewable energy, environmental infrastructure, and they're operating since 2007. The company is among Israel's solar pioneers and was actually the first company to connect a solar facility to the grid. We have signed 253 megawatt hour energy storage contract with Doral Renewable Energy Resources Group, and this is actually Israel's first DC-coupled liquid-cooled energy storage project, and it's going to further enhance the stability and reliability of our national grid in the view of the increasing market growth of PV-based plants. So the 4-hour liquid-cooled energy storage system slashes the capital on this site as well and operating expenses due to its pre-assembled and easy installation design, as well as more effective cell working environment, which once again substantially slows down the capacity loss rate. Meanwhile, the DC coupled design is streamlined and doesn't need an additional power conversion system and a medium voltage station, which is cost saving for the project. So we'll go into more details on that as we move along in this webinar. So I'll sum up this portion of the webinar by mentioning 3 cool things that you may have not known about energy storage system liquid cooling. First of all, by now you should know, because I mentioned this on the previous slides, but in order to increase the electrical generation, the liquid-cooled energy storage system innovatively uses a modular DC-DC converter and enabling the battery to be fully and flexibly charged and discharged, ensuring the optimized plant performance. Second point, which I found phenomenal, is that Sungrow, on its safety front, has 0 fire accidents. This is especially important given the fact that fire accidents on battery energy storage sites can be quite difficult to put out a fire. They can be quite contagious to nearby containers, and we are very proud to say that our design is very aware of the safety elements, and we have a section to talk about that later on here in this presentation. And so far, we are keeping our track record of 0 fire accidents. Third point is that Sungrow Energy Storage Division has actually been involved in battery energy storage systems since 2006, meaning that we're active in this market for more than 15 years. And so far, to top it off, in 2021, we've shipped 3 gigawatt hours of energy storage globally. Obviously, in 2022, we're looking to bypass this number by far, and hopefully on our next webinar, we'll have more figures for you on that. So it's been a pleasure speaking to you this morning here from Israel, and I'm going to hand it over to my privileged colleague, Yan Mu, for the next section of this presentation. Thank you very much.
Thank you, Zvi. Thank you for your presentation. Hello, everyone. My name is Yan Mu. I'm the System Solution Manager of Sungrow and responsible for the ESS projects in Europe and Israel. First, I would like to briefly introduce the current trends and issues of energy storage in renewable energy industry. As you can see from the data on the chart, by 2050, the forecasted installed capacity of solar and wind energy worldwide will reach 145 terawatts, with 86% of renewable energy generation. Accordingly, the installed capacity of energy storage will also reach over 700 gigawatt hour by 2030. At the same time, a large utility scale energy storage system faces several problems and challenges. High initial investment, high O&M, costs, and the safety issues. Until now, most battery storage systems have used HVAC for air cooling and the direct parallel connection of multiple battery racks to increase energy density. This has led to many problems, such as high auxiliary power consumption, inefficient heat dissipation, barrel effects of the storage system, and so on, resulting in lower projected revenue. Sungrow's liquid-cooled battery storage system is not only able to improve these problems from various aspects, but also able to provide total system solutions, from battery cabinets to MV transformers, from AC coupling solution to DC coupling solution, to meet different applications in a variety of scenarios. I will now describe how Sungrow's liquid-cooled energy storage system can improve these problems in three aspects. First is the CapEx. This picture shows the construction of Sungrow's liquid-cooled battery cabinet, consisting of the liquid cooling unit, the DC-DC, we also call it as a cluster controller, the battery, and other auxiliary systems. The entire battery cabinet is assembled in advance completely in the factory. After being transported to the site, no further manual installation is required. This will save significant installation time and costs. Also, the liquid-cooled battery cabinet has a highly integrated and compact design to increase the overall energy density. The single-sided door design also allows back-to-back arrangement on site, which also reduces the system footprint, allowing the whole system to be used on the sites with limited area and lower the land costs. Thanks to the liquid cooling system, the temperature difference between the batteries in the cabinet can be controlled to within 3 Celsius, thus increasing the life of the system and the amount of available energy capacity, increasing the profitability of the power plant owner. So why does lowering the temperature difference of the batteries can increase its life and the usable capacity? This is because lithium-ion batteries have different discharge efficiencies at different temperatures. The ideal operating temperature for lithium-ion batteries is about 25 Celsius. Too high or too low temperature will reduce their discharge efficiency and life. If the battery temperature difference between cells in a system is too large, will cause the change in their internal chemical substance, which will lead to different discharge efficiencies and lifetimes. At this point, the usable capacity and lifetime of the whole system will be determined by the worst units that make up the system, which is known as the barrel effect. Therefore, reducing the temperature difference between the different cells in the system can significantly reduce the barrel effects. And furthermore, the Sungrow's battery cabinet has integrated DC-DC. The battery racks are connected to their own DC-DC so that the different battery racks in the same cabinet can be controlled individually. In traditional practice, the battery racks are connected in parallel to the output. So as it's not possible for each rack to be in the same state, there is an imbalance between the racks, with some having more capacity and some having less. Due to the barrel effect, when the battery rack with the least energy capacity is discharged, the system will stop discharging, and then the energy capacity in other batteries cannot be fully utilized. The same applies to charging. The system will also stop charging when the rack with the most energy capacity is filled. In this case, if the system does not stop charging or discharging, then for some batteries there will be an overcharge or over-discharge, which is very dangerous. As you know, if a battery is frequently overcharged or over-discharged, it can cause it to catch fire. In addition to this, In addition to this, directly parallel connected battery racks with different levels of energy capacity can lead to differences in voltage between the racks, which can then create current loops between the racks. And this can also lead to a reduction in usable capacity and battery life. However, with the battery rack connected to the DC-DC, each battery rack can be controlled individually. If the barrel effect occurs, the DC-DC allows the battery racks to be charged or discharged at different power rates, ensuring the different battery racks can be discharged or charged at the same time, solving the barrel effect. Also, the DC-DC acts as an isolator, eliminating the creation of current loops between different battery racks. Next, let's talk about the OPEX. The reason why liquid is used for cooling instead of air conditioning is that the air has a very low thermal conductivity. It is not very efficient at cooling and dissipating the heat. The use of liquid allows for battery heat dissipation and cooling while consuming less auxiliary power energy. This increases the system charge and discharge capacity and reduces operation and maintenance costs. We know that the most customers now require that auxiliary power consumption should be considered in the system design, system usable capacity and efficiency calculations. The lower the auxiliary power consumption, the higher the usable capacity and the efficiency of the system, and the higher the profitability of the customer. Another advantage of using DC-DC is that the system will be more flexible and easier to configure and maintain at a later stage. It is possible to configure a battery cabinet with racks containing different numbers of battery modules without worrying about the barrel effect. The racks can also be replaced individually at a later stage if failure occurs. And in addition to the rack level, for the system level, there's no need to add additional PCS or medium voltage equipment during the later augmentation to the power plant. The additional battery cabinets can be directly connected to the existing PCS and mixed with the old battery cabinets. This not only saves additional investment, but also eliminates the need for additional grid connection applications. The third point, and is the one that's very important to all customers, is safety. The use of liquid cooling system brings many benefits, as I have just mentioned, but at the same time, it also brings certain risks. The most important issue is how to prevent the leakage of the coolant. First is the connection part. Sungrow has combined its proven experience in wind energy with a patented connector. This type of connector has been used in over 100,000 wind power converters with 0 failures. Also, in terms of leakage detection, intelligent leakage detection devices are integrated inside the battery modules and inside the battery cabinets, which detects a leakage fault and immediately alerts and stops the system. The other is the fire protection system for the battery cabinets. In addition to temperature and the smoke detectors, we have also integrated a combustible gas detector and an active exhaust system that can detect combustible gases and vent the gases in the first instance before a fire breaks out, preventing further risk of combustion and explosion. In the event of a fire, we have also used a water fire sprinkler system to minimize the flames as much as possible. and additional aerosol is also optional for the cabinets. We have also designed the battery cabinets with the risks of heat diffusion in mind and are able to keep the hazards to a minimum without injury to people or causing the whole power plant to burn. The most important point, of course, is that so far there has not been a single fire incident at a facility with Sungrow's equipment. So in conclusion, Sungrow's liquid cooling system has lower costs and higher energy discharge for the customer. It's more flexible to configure the system and very safe to operating on-site. And next, I will present two typical solutions for Sungrow energy storage systems, the AC coupling system and the DC coupling system. These two diagrams show a brief connection difference between the two solutions. The diagram on the left shows the DC coupling, which is mainly intended for use with the PV plants, where the PV modules and the batteries are connected parallel to the DC side of the PV inverter with DC coupling function. The diagram on the right shows AC coupling, where the energy storage system is connected in parallel with other power generation or consumption equipment on the AC side. Sungrow, as one of the world's largest supplier of inverters and PCS, has more than 20 years of experience in power electronics development. As you can see here, for energy storage systems, the battery is only an energy storage device. The energy ultimately needs to be transferred to the grid through power electronics, and this is where Sungrow excels. Sungrow's PCS have also passed the most demanding standards, such as G99 in the UK and VDE in Germany. They are able to meet the various high standards required by different countries for grid connection and grid support services. We have just established an energy storage technology center in the UK recently, and we are also working with universities and research institutes to explore renewable energy grid connection technologies and requirements. For AC coupling, this is a traditional way of connecting power generation equipment with greater flexibility and a wide range of applications. The main applications currently used in energy storage plants are energy shifting, peak shaving, energy arbitrage, grid frequency regulation, and black start. The application of DC coupling is then relatively homogeneous, mainly supporting and complementing PV plants. For example, smoothing the discharge curve of unstable PVs or absorbing excess PV discharge and then discharging the energy to the grid when the PV generation is insufficient or completely unavailable. So in general, there are several operating concepts for DC coupling. We will use these diagrams as an example. We assume that the maximum charge and discharge power of the energy storage system is 1.25 megawatts, and the rated power of the PV inverter is 3.125 megawatts. At this point, when the PV power generation exceeds the maximum power of the inverter operates at full power, and then excess power from PV can charge the battery. Also, if the power generation from PV does not reach the rated power of the inverter, the battery system is able to discharge to the grid together with the PV at the same time. And alternatively, we could have the energy storage system charged from the PV at maximum power and discharge the excess electricity from PV to the grid. Or we can also charge the battery with all energy from the PV without discharge to grid if the charging power from the PV is less than the maximum charging power of the battery system. And At night, when there's no sunlight, we can also disconnect the PV and use the battery system to discharge to the grid or charge the battery system from the grid. Finally, let's talk about some Sungrow's latest typical projects and applications. In 2021, Sungrow has shipped the battery storage system with over 3 GWh capacity all over the world. And this is a project in the USA, grid connected in 2021, which was once Sungrow's largest DC coupled project, but of course has now been taken over by Doral in Israel. And this project uses an air-cooled system. Doral uses the latest liquid cooled system, which I've just introduced earlier. This was Europe's largest battery energy storage power plant. Its main application is to support the grid and earn revenue through frequency regulation services. And the owner has also signed another contract with Sungrow to build a second 50 megawatts, 100 megawatt hour energy storage plant next to this site. And this project in the USA was once the world's largest black start project using a battery energy storage system as a power source. And meanwhile, in addition to the nearly 800 megawatt hour projects in Israel just mentioned by Zvi, here is a list of some of the major projects in the USA and the UK for which Sungrow has already signed the contracts. Sungrow has many years of experience in global renewable energy projects as one of the largest renewable energy equipment providers in the world. For the project's owner to operate a power station, signing a contract to buy equipment is the easiest thing to do. What matters is the supplier's ability to deliver the equipment, and above that, the most important thing is the plant operation and maintenance at a later stage. So for Sungrow, no matter what the situation is, Sungrow is always the first responsible party for the energy storage equipment. We have complete after-sales services teams in all regions of the world, capable of responding to customers' needs in the first instance and providing warranties and services for the overall equipment. I sincerely appreciate your attention to my presentation. Thank you. Now,
Excellent. Well, thank you very much, Zvi and Jan. Fantastic presentations, and again, a really interesting topic that I can see just from some of the questions that we've had from our audience today has really resonated. As we've alluded to, now we can open the floor to our audience for questions. Once again, if you do have a question for either Zvi or Jan today, please use the dialog box on your screen. We've been collecting them throughout the presentation, so we have quite a few to get through already. I guess just to start with, this is something that's come up, and I'm kind of acutely aware that it is quite an issue for the energy storage sector globally at the moment. Supply chain issues are something that we're hearing plenty of discussion around. How is Sungrow actually looking to handle that tightness of supply and pricing increases that the industry is seeing, particularly with lithium ion?
Great. So I'll take that question. Actually, before I answer that, I just want to comment on one of Jan's last slides where he mentioned that signing the contract is the easier part and delivering is the harder part. So as someone who's signed those contracts, it's not easy to sign the contracts, but I agree with you that it's more important to deliver the right way, and we're working on that very strongly, and we've already succeeded in delivering many gigawatts. So that's just one comment, and thank you very much for your presentation, Jan. So how do we cope with the delivery chain? So indeed, it is a challenge. First of all, we have the increasing pricing of the lithium iron. As whoever is not aware of that, then The price increases on that have been just something off the charts, and it's like a hockey stick increase where things are jumping up, and that indeed is where Sungrow actually comes in with an advantage, because we have pre-purchased large capacity of batteries, which is what is the main component of the batteries is the lithium iron that affects those prices. So we are still able to supply, although the prices are increasing, we are still able to go ahead and deliver those batteries at a very, or the systems at a very attractive and competitive price. With that being said, there are challenges of increasing pricing. So whoever is still contemplating on whether to buy now or to wait, I don't see those prices going down at any time in the near future. We have the electric vehicle market that are pushing the prices up, as well as other factors. So it is recommended to sign, to get into an agreement sooner than later, as those prices are probably going to stay high. Shipping wise, there are challenges on that as well. But obviously it's something that we are known as a global, let's say, we know how to ship globally in large amounts and very effectively. So I think that that's something that I would not be worried about either. And we've effectively been doing that globally. As I mentioned, operating more than 150 countries. So all in all, we're on the right track to go ahead and deliver accordingly to the right and to meet the client's requirements. I hope that answers the question.
Yes, it does. Thank you very much. Now, a couple of questions, I've alluded to this. Obviously, it's fantastic to have that level of detail in a presentation and to kind of hear you both speak about the product, but there's nothing quite like actually seeing it in person and being able to really get hands-on. Where can people start to see the system being deployed or demonstrated with upcoming trade shows, that kind of thing?
Yeah, so I'll take that one as well. First of all, we're going to be at Intersolar in Munich, Germany on May 11th, and everybody here is welcome to join us at the Intersolar. We're going to have a mock-up demonstrated over there at the Intersolar exhibition, so you're more than welcome to come and see us there. Booth number, etc. We can probably post that. You can find it online as well. I don't know offhand what booth we're at, but we're going to have rather a large stand over there, and we'll have our professionals will be presenting, and you'll be able to ask questions and see the system as a mock-up. First deliveries in Israel are planned for Q3 of this year, perhaps even end of Q2. So you should be able to see those actual systems being delivered to Israel and installed shortly after that. And I believe that we have systems going globally even before that. So that's as far as seeing the actual product.
Great. So I've been collecting some of the more technical-minded questions. So, Jan, these questions might be better aimed at you. With the benefits and the capabilities of the liquid cooling system that you've run over and its impact on temperature, I presume the system then becomes more powerful in hotter climates and really comes into its own there.
Sorry?
Is there sure, given the benefits of the liquid cooling system and especially around the operating temperature, is there an inherent benefit of this system in different geographies, so whether the climates are hotter? Jan, I think you're muted.
Sorry, can you hear me?
Yes, we've got you back now.
So our liquid cooling system can work between -20 Celsius to 50 Celsius. And with the liquid cooling technology, we can maintain the temperature inside of the battery cabinet at fairly, fairly proper temperature for the battery cells to work. So no matter where the project is, we can use the battery liquid cooling battery cabinets.
Yeah, so just to add on to that, Liam, to your question, and to the audience's question, I think that you know, we're pretty agnostic to location-wise, since we control the temperature within the system, so we know how to go ahead and manage that, and we know how to keep within the boundaries of what temperature we need to be at. So we can basically operate anywhere in the world as far as that goes.
Excellent. And I think one thing that some of the audience have touched on, there's obviously some quite landmark statistics in your presentation on fire safety, that kind of the figure of having no safety or fire incidents is really quite compelling. Asset insurance is such a key area for energy storage, especially against the backdrop of fire incidents and some of the issues that we've had with fire safety and prospective overheating. Has there been any kind of anecdotal response from insurers to the liquid cooling so far? Have they engaged with the concept? Are they aware of it? What's their response been?
Well, I can tell you that, first of all, thankfully, we have not had any insurance claims. As I mentioned, and as Jan has also mentioned, we have had 0 fire incidents. With that being said, we have full insurance for the systems, comprehensive insurance that we provide as any agreement that we go ahead and sign with our systems. So blended with the fact that 0 incidents and full-blown insurance policy that we insure, I think that we're pretty covered on that end.
Great. And with the overall maintenance, the practices from the liquid cooling system versus a traditional air cooling system, how do they compare? What's the impact on the OPEX of a liquid cooling system?
I'll let Jan answer that.
So for liquid cooling system, as we know, we can use less auxiliary power consumption for the system, for the battery cabinet. We will get more usable capacity of the system, which brings more dischargeable energy to grid. And another is all the battery modules are pre-installed here in our factory, so the customer doesn't need to manually install all the batteries on site, which can also save a lot of the investment. Yeah.
Excellent. And this might be a bit too sensitive. Is there any information that you can share on the type of liquid that's used to cool the system, how frequently it needs to be topped up, what the refilling procedures are? Is there anything you can share on that topic?
So you mean how to refilling the coolant of the system?
Yes, exactly.
Well, we do have a menu we do have an instruction and menu of refilling the liquid coolant, but I can't just describe it. Yeah, on the webinar.
Sure. So just so that there is detail available from Sungrow around the refilling.
Yes, of course. Yeah.
Perfect. And then just, I think this is maybe with you again, Jan. Could you share some details around system sizes and the modularity? So for instance, what's the smallest system size or capacity, or how does it scale according to, and perhaps we could then talk about the power conditioning system as well, and some of the limitations there.
Well, for the liquid cooling battery cabinet, the minimum energy capacity of one cabinet is around 2 MWh, and the maximum and the max capacity is 2.7 MWh. And we can, of course, combine different numbers of the battery cabinets together to meet the customer's requirements. And the purpose of the liquid cooling battery cabinet is for utility scale projects, which means for large projects, and also because of the back-to-back arrangement, we can reduce the footprint of the whole plant.
Okay, great. Svi, this might be a question for you. Obviously, we've said before that the product's available. It's available now. It's being installed. It's available across the world. Could you perhaps go into a bit more detail around its availability? How do people go about actually procuring a system like this? Where does that discussion start?
Sure. First of all, thanks for the question. We're very welcome to receiving requests, and obviously the stages that we go through are first designing the system according to the needs. For example, in Israel, we do 4-hour energy storage systems. In the UK, we have 1 to 2 hour energy storage systems. We have the AC coupled, we have DC coupled, we have liquid cooling, we still also have air cooling. So it really depends on what the client needs. And we know how to go ahead and optimize that together with the engineering team from the client. And once that's engineered, which can take a few weeks, maybe more, depending on the pace and etc., then we'd go ahead and put that into a contractual agreement, which can also take some time. And then we have a certain lead time for the delivery. And then we're talking about delivery, whether it be FOB, Shanghai usually, or it can be SIF at the port of destination, or DDP in certain cases, if to the site. And that lead time can range anywhere between, usually it'll take 4, 5, 6 months for FOB Shanghai, and then giving transportation limitations as much as that takes, from weeks to maybe a little after a month for the shipping itself. So it really depends at the time of when and what our pipeline is like and where holidays fit in, etc. But that's more or less, give or take, the time range that we're looking at for deliverables. I hope that answers the question.
Yeah, excellent. Thank you very much, Svi. This again could be a bit detailed. Plenty of people are asking about this. The system clearly has inherent benefits over traditional air cooling systems. Is there any available details around the impact of liquid cooling on the system capex? So presumably it's more expensive. How more expensive is it?
Well, according to our calculation, the liquid cooling system has less capex than the air cooling system because of the high energy density, and yeah.
Perfect. So it's not necessarily more expensive, but it delivers on energy density, so more than kind of pays for itself then in the longer term. Fantastic. I'm just scouting through these questions now. Perhaps a question here: is the system supplied as a turnkey solution on site?
Yes, it's a turnkey solution. We have battery cabinets and inverter with transformer and RMU skid, or PCS with transformer and RMU skid.
Excellent. And then we've had a couple of questions around guarantees, warranty periods, life cycle guarantees. Is there anything you can share around that?
Sure. So basically, we have a full-blown guarantees. We do everything. I mean, we guarantee delivery. The delivery time, we have that as well. We guarantee performance. We have warranties built into the contractual agreement, and basically, we're giving our full Sungrow backing to it. Everything is with the specific number of years associated to it, and there are different components within the system that have different years that are associated to those different components. And it really depends also on let's say, I mean, we have our fixed numbers, but it can vary a bit on size of the project, etc. If it's a very large project, then maybe there'll be more openness to some slight adjustments in that length of the duration of that. And then there is a built-in warranty period that's free of charge, and then there is a possibility to extend the warranty on the different components for additional cost, which we would be providing the services at a fixed fee, and that also changes per location globally. So I hope that answers the question.
Fantastic. Yes, it does. Perhaps one last question, Jan. This might be best explained by you. How does the cooling system affect the aging of the battery? Is there any impact? Is there anything that Sungrow has witnessed in its testing?
Yes, of course. The coolant is very important for heat dissipation. The liquid is better than air, as we know. The liquid has a larger sorry, I forgot the word of the, and with liquid coolant we can have better heat dissipation, which will improve the life of the battery cells. In this way, the customer can use the battery system longer than the air cooling system. I hope this can answer the question.
Great, thank you very much, Jan. Unfortunately, that is all we have time for today. If we haven't gotten around to answering your questions so far, then we will endeavour to answer them privately. Of course, the presentation and recording will be available to all attendees shortly. A huge thank you to Sungrow Power for supporting the webinar today, to Zvi and Jan for presenting, and indeed all of you for your attention this morning. Thanks again, and we hope to see you next time.